topic is alkene. Alkene, just general formula CnH2n. This is the general formula. It start putting value of n. If n is equal to 2, C3H6. Name of this is ethane, and it is called as propene. Now let's see the preparation of alkene. Dehydration basically means removal of water. Removal of water is called as dehydration. Dehydration of alcohol means alcohol से water को remove करके आप alkene बना सकते हैं. That is the reaction. Let's see reaction. Let's have it is C2H5OH. C2 1 2 3 4 5 C2H5OH. C2H5OH. It is, that means it is ethanol. Okay. Now removal means elimination, or you can say elimination means removal. This reaction is an elimination reaction that you are sure about. Now let's see. Generally dehydration के लिए सबसे concentrated H2SO4 is one of the most powerful dehydrating agent. That means it removes water from substances easily. You are going to use here is concentrated H2SO4, which act as a dehydrating agent and is which is really powerful dehydrating agent. It is a really powerful dehydrating agent. Now concentrated H2SO4 as a dehydrating agent. Now water is removed. Suppose this is the molecule that you are going to remove, that is water. Now you have this. कार्बन को अपनी चारों वैलेंसीज पूरी करनी है. That means here is going to come a double bond. डबल बॉन्ड आते ही कार्बन की चारों वैलेंसीज कंप्लीट. 1 2 3 4. It is your alkene. That means this ethene. The common name for this is ethene. आपने यहाँ इथेनॉल से इथीन बनाया in the presence of concentrated H2SO4, the presence of concentrated H2SO4 which is reacting as a dehydrating agent and which is quite powerful. Now the general thing that elimination reactions generally takes place at higher temperature. Elimination reaction elimination reaction. Elimination reactions generally occurs at higher temperature only. So we put it. So we at high temperature only. Okay. Let's see some example. We are going to start from ethanol only. CH3 CH2OH concentrated H2SO4 we're gonna get ethene. CH2 CH2 See the mechanism of this reaction, that is CH3, CH2 and OH. Ethyl, it's ethanol, concentrated H2SO4, and this is your product. Let's see the mechanism. This is your reactant. H2SO4 को आप ऐसे भी लिख सकते हो, as you know H2SO4 H2SO4 is an acid, so ये H प्लस लूज करने की टेंडेंसी रखता है. H प्लस आया यहाँ, H2O, this is your protonated alcohol, protonated alcohol. This step is a fast step, and now here comes the rate determining step, your removal of water. This step is slow. This is your RDS, that is removal of water. H2O is removed. अगर H2O निकला है तो आपके पास बनेगा कार्बोकेटायन. कार्बोकेटायन. Now H2SO4 अपना एक एक्टिवेटेड हाइड्रोजन पहले ही डोनेट कर चुका है. H2SO4 अपना एक हाइड्रोजन पहले ही डोनेट कर चुका है. दैट मीन्स, and here this is your this is your कार्बोकेटायन. एंड आपका रिमूवल ऑफ वाटर ही RDS होगा. दैट मीन्स आपका जिस स्टेप में वाटर का रिमूवल होगा वही स्टेप स्लो होगा और वही आपका रेट डिटरमाइनिंग स्टेप होगा. ओके, लेट्स सी. नाउ यहाँ से H plus will come here. That means CH2 double bond CH2 and H2SO4. H2SO4 वापस ऐसे ही रिएक्शन में मिला है आपको. दैट मीन्स इट एक्ट एज ए कैटलिस्ट. So as we know, H2SO4 here act as a catalyst, and आप सोच रहे होंगे कि यहाँ पर हाइड्रोजन आयन गया कैसे, H प्लस आयन गया कैसे. H प्लस डोनेट करने के लिए आपको एक बेस की जरूरत होगी, एंड H2SO4 स्ट्रॉन्ग एसिड है. is a strong acid. That means it forms a weak conjugate base. H2SO4 forms a weak conjugate base. Weak conjugate base of a strong acid. You can write conjugate of a strong acid as a weak base. So here it acts as a base. So it accepts its H plus, and here is your alkene. This is your RDS. Removal of water is your rate determining step. Note few lines in your notebooks. In this reaction H2SO4 act as a catalyst. Reaction is E1, or you can say reaction follows E1 mechanism. How even? Because रेट डिटरमाइनिंग स्टेप में केवल एक ही रिएक्टेंट की कॉन्सेंट्रेशन के प्रोपोर्शनल होता है. Because rate of the reaction is directly proportional to alcohol only. That means it is a unimolecular reaction. This is an experimental value. You can't find it theoretically. And as reaction intermediate is कार्बोकेटायन. अगर कार्बोकेटायन है that means you have to rearrange if possible. Now we were saying that ease of dehydration is 3 degree and 2 degree then 1 degree, because as you know the stability of carbocation 3 degree more stable than 2 degree than 1 degree. That means rate is directly proportional to the stability of carbocation, because in the rate determining step carbocation is involved and the removal of water is your rate determining step. See, this is your 3 degree carbocation. This is 2 degree. This is 1 degree. 3 degree carbocation, 2 degree carbocation, 1 degree carbocation. Now the stability, as you know, CH3 is a plus I group. So it will donate electron, that is it is an electron releasing group. So it is an electron deficient species. So if it is getting electrons from any other species, so its stability is increased. 3 degrees more stable than 2 degree than 1 degree. That's how you can explain why the ease of dehydration is directly proportional to the degree of alcohol. Now this is a reaction, concentrated H2SO4. First step will be protonation. Let's see this reaction in detail. This is, it's a fast step and this is a slow step. This is removal of water. This is your carbocation. Rearrange if possible. But here you can't rearrange because stability is not increasing. Alpha, beta, alpha, beta. This is your alpha. In this reaction, you have to remove alpha से OH and beta से H. Now you या तो ये वाला बीटा एच रिमूव करोगे आप या फिर ये वाला बीटा एच रिमूव करोगे आप या फिर ये वाला. Set the product is your major product in this reaction. Which is your major product? Let's find out. Stability of alkene you can predict by alpha, calculating alpha H. Calculate here. It is 6 alpha H and here are 2 alpha H only. The hydrogens directly attached to the double bonded carbon atom are your alpha H. So this is your major product. It's such a product is major product. That means your more stable alkene is your major product. More stable alkene is the major product. More stable alkene is the major product. Let's see some more examples. CH3, CH2, CH2, OH. Dehydrating agent, concentrated H2SO4. Heat. CH3CH2OH. Now our first step will be protonation. This is the first step. एक होगा slow step, which is rate determining step, which is your plus water. Removal of water is rate determining step. आपको यहाँ कार्बोकेटायन बनाया आपने, अगर आप रीअरेंज कर सकते हैं then you have to rearrange if the stability of carbocation at any point is increasing. You can H minus shift हाइड्राइड की शिफ्टिंग करा के आप इसकी स्टेबिलिटी इंक्रीज करा सकते हैं, बिकॉज यहाँ पर कार्बोकेटायन के पास 2 अल्फा एच और यू कैन से इट इज 1 डिग्री कार्बोकेटायन, यू कैन मेक इट 2 डिग्री कार्बोकेटायन. It is 1 डिग्री कार्बोकेटायन. H माइनस हाइड्राइड की शिफ्ट के बाद आपके पास होगा 2 डिग्री कार्बोकेटायन, और यहाँ पर आपके पास अल्फा एच भी ज़्यादा होंगे ऑब्वियसली. यहाँ पर आपके पास 2 अल्फा एच हैं, 5 alpha H. So stability is obviously increasing. Now base, the conjugate base of a strong acid, conjugate base of H2SO4, जो इनमें से किसी भी बीटा, ये भी आपका बीटा एच है और ये भी आपका बीटा एच है, इनमें से किसी भी बीटा एच से हाइड्रोजन एच लेकर जाएगा बेसिकली. लेट्स सी, bond CH3, you will see which is this major product. Of course you can see, obviously this is the major product, this is more stable, and this is your minor product. Here you can see the rearrangement, बट आपको रीअरेंज सिर्फ तभी करना है जब हर एक स्टेप के बाद कार्बोकेटायन की स्टेबिलिटी इंक्रीज हो रही होगी, अदरवाइज यू कांट रीअरेंज अ कार्बोकेटायन. लेट्स सी सम मोर एग्जांपल. इस बार थोड़ा सा अलग टाइप का रिएक्शन देखते हैं. इस रिएक्शन के थ्रू मैं आपको कार्बोकेटायन का रीअरेंजमेंट भी समझाने की कोशिश कर रही हूँ. प्रोटोनेशन, fast step, it is a fast step heat obviously, and this is your slow step, which is your RDS, which is the removal of water. वाटर को आपने रिमूव करा दिया है. ये CH2। अब आपके पास कार्बोकेटायन आ चुका है और आप कार्बोकेटायन को आपको रीअरेंज कराना है टू इंक्रीज द स्टेबिलिटी। अब स्टेबिलिटी कैसे इंक्रीज कराएंगे? हाइड्राइड शिफ्ट होगा नहीं यहाँ पर, क्योंकि इस वाले कार्बन के पास कोई हाइड्रोजन नहीं है, तो यहाँ पर होगा CH3 माइनस शिफ्ट। CH3 माइनस बनकर बाहर निकलेगा, दैट मीन्स मिथाइल शिफ्ट। मिथाइल शिफ्ट होगा यहाँ पर, विच इज CH3 माइनस शिफ्ट होगा यहाँ पर, और आपका कार्बोकेटायन की डिग्री भी इंक्रीज करेगी। कार्बोकेटायन हो, अभी तो आपके कार्बोकेटायन की स्टेबिलिटी काफ़ी ज़्यादा बढ़ चुकी है। यहाँ पर 0 अल्फा एच, यहाँ पर 3 6 8 8 अल्फा एच, 0 to 8 अल्फा एच। ये आपका 3 डिग्री कार्बोकेटायन है, विच इज द मोस्ट स्टेबल कार्बोकेटायन। अब आपके पास एक बेस होगा HSO4 माइनस बेस। आपके पास बीटा हाइड्रोजन रिमूव करने के लिए 3 टाइप के बीटा हाइड्रोजन अवेलेबल हैं इस बार, which you have to decide which one you want to remove. This beta hydrogen, this beta hydrogen, and this one as well. CH3 CH3 C double bond CH CH3, ये प्रोडक्ट बन सकता है आपके पास, या फिर CH2 double bond C CH3 CH2 CH3. Now you have to decide which one is your major product. This and this beta hydrogen and this beta hydrogen is same. Sorry. Here your product have 5 alpha H. This is your double bonded carbon atom, and these are your alpha H. 3 to 5. 3 3 3 6 9 alpha H. 9 alpha H. That means this is your major product, which is more stable alkene. Major alkene. Now one more important thing to remember is that yes, it is, ये आपका अल्कोहल है और इससे आपको एल्कीन बनाना है। ओके, आपको फिर से कुछ डिहाइड्रेटिंग एजेंट चाहिए, दैट बेसिकली मीन्स आपको क्या मिल सकता है, P2O5, आपको मिल सकता है Al2O3, और आपको मिल सकता है concentrated H3PO4. बट ऑन हीटिंग, बिकॉज एलिमिनेशन रिएक्शन थोड़ी ज़्यादा हीट होगी तभी प्रोसीड करती है। ओके, Al2O3 concentrated H3PO4, phosphorus pentoxide concentrated H3PO4 on heating or Al2O3. But on heating, these Al2O3, P2O5, ये आपको मिलेंगे वेपर फेज में, वेपर फेज concentrated H3PO4. These all are dehydrating agent. Okay, thank you so much for watching. See you in the next lecture.